Bismillahirrahmanirrahim. Okay, welcome back to another video. Today I'm going to be teaching my students who are sitting here, Mr. Ramiez and Ifra. Okay, we're going to be looking at three-dimensional trigonometry. Right. So we'll be given a cube. The cube is A, B, C, D on the bottom base part. And the top part is going to be P, Q, R, S. So let's look at the kind of questions that we have over here. So this is the kind of questions we have. Hope you will see that as well on the video. We need to work out, it says that in the cube shown, find BD. Let's look at BD. So BD is that length there. So let's look at how do we work that out first. Right. One of the most important things we have to realize in three-dimensional trigonometry is the shape is a 3D shape. What looks like an obtuse angle is most of the time actually a right angle. We have to look at the nature of the shape. Because we have here a cube has very particular characteristics. So the base of the cube, even though this here looks like an obtuse angle, is actually 90. It's just the way that the diagram has been drawn in 3D view that it looks more than 90. So those are the things you have to, it's very important in order for you to understand this topic well. So this angle here that looks like an acute angle is also 90 because it's just the way the diagram has been drawn, and that here at the bottom is a square. It's a square of the cube. So I'm going to draw in here now.
All angles in a cube or cuboid are 90 anyway.
That's right, 90. So I'm going to draw in here at 90 degrees. Okay, so we have a 90 degrees. It says to us here in the diagram, each side, obviously it is a cube. A cube is symmetric in the sense that every single length is... Okay, so if we look at this bottom shape over here, we have a length here, a right angle, and then another length, and that is also 6. So in a sense, if you wanted to redraw what looks kind of a bit of a squashed triangle in real life, okay, I'm just going to check that the video is picking all that up. Okay. Right, I think I need to write in this. It's not picking up.
Should I go and get...
That's right.
So did you get the video that I posted last week?
Okay, right now, if we look now at this triangle that we have over here, so the triangle in question is this one here. If you follow my pen, this is the triangle in question, and the blue line B to D I'm also going to put in here as well in blue. Okay, so here we've got our traditional two-dimensional view. Everything that's a right angle looks like a right angle, but here it doesn't. So I'm just trying to show you the difference. Okay, just trying to show you the difference of the view of what this looks like here and what it looks like to us when we're doing the question. Okay, now if you want to work out the length BD in our triangle here, we have to look, we know the bottom, the base and the height. So we know two sides, we're going to work out the third side, so we use Pythagoras theorem. So if I label my diagram, that's my hypotenuse. Okay, so what we say that the hypotenuse squared is equal to side 1 squared plus side 2 squared. Okay, so what we're saying here now is BD squared is equal to 6 squared add 6 squared. So now in order to work out the blue side, we need to use Pythagoras theorem, which is the hypotenuse squared is equal to the sum of the other two sides squared. So now you put in the values, 6 squared add 6 squared, that gives you 36 add 36.
Which is, I think, 72.
Okay, 72. Now remember, we want to work out BD, but here we have BD squared. So, Ramiez, can you square that for me please on the calculator? So we have B, the opposite of squaring, take the other side of
square root. So 72 square root.
72 square root it please.
8.4.
Okay, now so BD, what do we get for BD?
8.48.
Okay, does it give you first one as a
The squared number.
yeah, like that?
6 squared 2.
6 root 2.
Yeah.
Okay.
Yeah, like that.
Okay. Okay. So we have BD is equal to 6 root 2. Okay. Right. You can't see my head.
No, just that part.
What is that?
You can't see your lips.
You can.
Shh, okay. Let's try that.
So we're having technical difficulties.
Okay. Can you see me now?
No, nothing.
That's even worse. Now we just did that.
You need to crouch down a bit.
I've got an idea. Excuse me folks, there's a slight technical difficulty here. We just need to get I'm sure you don't want to just see my lovely beard in the video. Let's see if we can.
Yeah, that looks better now. Yeah, I think we'll get you there now. Let's do.
Okay.
It's less.
No.
It's less of a beard.
I think you need to push it
I
up.
think it's gotta go more up and back. If you make this up fine, yes.
Just get the, as long as I get the board on there, that's okay.
Yeah. We know that you're in the video from the start anyway.
Okay.
Just push it really high up.
Oh, that's okay, don't worry.
Tilt it down.
Okay. Right, so we finished the first part of the question. I think there's some slight technical difficulty where you got just my lovely beard in the video. Okay, let's move on to the next question, next part of the question. So from our diagram here it goes calculate AS. Now, let's use a different colour now. Okay, where's my colours? Where's the colours on?
On this side?
Yes. Okay, now A to S is over here. So now what we're looking at is the back part of the cube, A to S. Now again, what I want to do now, I want to take that triangle out and put it over here. So let's redraw the triangle. And again, you have another right angle triangle over here in the back corner of the cuboid. Okay, so we have A over here, S over here, and D, a right angle. Now, the back part of the cube, the base, will also be 6 centimeters. Because every length is 6 centimeters. And we'll have a height that was also 6 centimeters. Now,
Trigonometry.
so if we look at this triangle here, this triangle is identical to the one we've just done. So you got 6 by 6, and then that's going to be the diagonal that goes across. So we can just really just copy the answer straight across from here to the. So we can make a statement and say A to S is equal to Okay, I'm going to leave the answers for the moment in root format, but simplified. For those students who want to get a final decimal answer, please feel free to put that into your calculators and get it out as a decimal number. But for the moment, I'd like to leave it at that. Okay, because that helps later on when we do other calculations based on this calculation. That way we have a very precise number. So this has got all the information stored in there rather than us having a huge decimal number that we round off and then we have rounding errors when we reuse that number again. So we've just worked out now 2 lengths. The second length we've got 3. Now you go to work out BS. Okay. Now BS. Okay, I'm going to use a different colour. Okay. Now BS is across here. Now if you look at the diagram here, BS that runs from one corner to the bottom corner, and again we have a situation where we have a height of 6 and then we have a diagonal here now, this diagonal. So let's redraw that diagram now. Okay, so here's our S at the top, there's the B at the bottom, and then you drop straight down to D, and then you drop straight across. So now what we've got here actually is a right angle here as well. So we've got a right angle, okay, because of the nature of the cube shape. So we have a right angle here. Okay, so B, D, and S. Now B to D, we worked out earlier 6 root 2. Now you will see the reason why I didn't decimalize it earlier and change it and start rounding it. Now I've got a precise number. 6 root 2 is a precise number. All the decimal points are all stored in there. Okay, now if you look at, now we've got to work out, we have to work out our SB. SB is over here. I'm going to highlight that in yellow. Okay, now, if you look at our diagram, here, D to S, if you can see from here, that's 6 centimeters, that's 6, so the height is the same at the back, so that will also be 6. Now, we have the similar situation where we know 2 lengths of a right angle triangle. We have to work out the yellow length over here, the highlighted length, so we use Pythagoras theorem again. So what is Pythagoras theorem saying? So BS squared, so the hypotenuse squared, this is the hypotenuse. Hypotenuse squared is equal to the sum of the other 2 sides squared. Okay. So now, if we have 6 root 2 and we multiply that by 6 root 2, that will give us what?
6 root 2 times 6.
If you do mentally, that will give you 36 times by a root number times by the root number gives you the number inside. So that should give you 36 times by 2. That should give you 72?
72, yeah.
Okay, lovely. And 6 squared will give you straightforward
36.
36.
Now we add them.
So we need to add them for me, please. So 72 at 36, 70 at 30 will give you
108.
That's right, lovely. So 108 is equal to BS squared. Okay, now we don't want to BS squared, we need to work out the length BS. So we need to
square root that.
Square root the answer.
We get 6 root 3. Yeah.
Okay. That is lovely. That's all come up nicely on the video. They're nice with the pens. Okay, now we're going to start working out some angles. Okay, now for the angles. Let's rip this page off for the moment.
Separate page.
I'm going to still use it. Okay, the angle that they've asked us to work out here, the angle SBD. Now the angle SBD, if you follow it, So we're going to work out the angle SBD.
It's like an igneous triangle.
So here's S, here's B, here's D. So the angle that they're looking for is this angle here in our three-dimensional diagram. Now if you look at this SBD, do you remember the triangle that we've just done over here? SBD. So we are now going to reuse this triangle. We're going to relabel this diagram on the other page and we're going to work out the angle over here. So it's SBD is in the same previous triangle that we just used. So let's now copy it up. Okay. Here.
Yeah, so
Okay, right. So the angle that we're interested in is
the B.
the angle there. SBD. So we've reused the previous triangle. Now to work out the angle there, we are now going to use not Pythagoras theorem, but we're going to use now trigonometry. Because we have a right angle triangle, we know two lengths. Actually we know the third length as well, but we're going to use these two lengths and we're going to work out the angle. So let's do a bit of trigonometry. So first of all, this is the angle I'm concerned with. So opposite angle is called the
Opposite.
Opposite the right angle is called the
Hypotenuse.
hypotenuse, and the leftover side has to be the
Adjacent.
and we always do the adjacent last because that's what's left over.
Yeah.
Okay, so don't try to label it first. Now, SBD is what we're trying to work out, which is this one over here. Now, we need to look at Sakatoa. Okay, can you see that clearly? I'm not moving around too much. Okay. Take more space, take it back a bit. Take more space. So don't bring it too far, leave it in one place. Okay, we have our camera girl. Okay. Alright, let's just move that back a bit more. Okay. You go see. Okay. You can't see that. Colours. Okay, I think I better use some dark colours. I've just been told by my camera person. Okay, now what do we know? We know the adjacent. No, yes, okay. The adjacent and we know the opposite. So we're going to follow the rule 2 ticks and a cross. So we're going to tick what we know and cross what we don't know. So we know the adjacent, so everywhere I see adjacent, I tick it.
Yep.
Everywhere where I see the opposite, I tick it.
So the formula is TOA to TOA.
That's right. Okay, so at the moment we want to work out the angle. So every time we see the angle, we cross it. So we are now looking for 2 ticks and a cross in one of the triangles, which is TOA.
Yes.
So let's just rewrite it again over here. Okay, so what do we know? So we know
The opposite and the adjacent.
the opposite and the adjacent, and we've got to work out the angle.
Yes.
So we cover this up with our finger. And the angle, the tan of the angle will give us opposite divided by adjacent. So we write that now. So the tan of our angle is equal to the opposite divided by the adjacent. But we are trying to work out not the tan of the angle, but we're trying to work out the angle.
So you have to do tan minus 1.
Correct? That goes over.
Yep. So
So we got to inverse the tan, so that gives you tan
minus 1.
minus 1 of the O
And
over A. So now we are ready now to start putting in our values to work out the answer. So tan minus 1.
equals.
So tan minus 1
Of
And the O value is 6
6 over 6 root 2
over 6 root 2.
equals
So the angle then will give us an answer of
35.26.
Let me just check your calculator display. Okay, to 2 decimal places.
Yeah.
Okay, that's given us to 2 decimal places. I'm gonna give a final answer as 35.3 degrees, and I'm gonna quote my accuracy here as 1 decimal place. Okay. Let's just double check. Oh, beautiful. Look at the colours, man. Lovely. Okay. Okay. Right. Now we have nearly finished one question. So if we look back at our question here, we have to work out BD, which we've done, AS, which we've done, BS, which we've done, and then we've got to work out the angle SBD, and that's the angle SBD, by the way. So that is going to be SBD. Now SBD, let me just, I think one thing I didn't go over in the beginning here. What does SBD mean? It means if you start from S, then you go to B, then you go to D, it's the angle enclosed by that, which is the middle letter. So that's the letter angle that we're talking about. So SBD is that middle one, the B one which we're looking at. That's the letter format, SBD. Okay.
So that's how you work out the angle.
Please don't get SBD mixed up with SPD. That's something else completely. Right, okay. The next one we have to work out the angle ASB. Right, so let's get back to our original sheet. Right, let's get back to our original question, diagram. They want us now to work out the angle ASB. Okay, where's ASB? ASB, ASB. Okay. Right, let's.
It's a bit of a tricky one to draw down.
Alright, let's just get the right colours. See the brown. Well, the AS is already there. And then the B is over here. Okay. Okay. So he wants us to look at the angle ASB. Right, let's put this to one side. Now, if you look at this, this diagram now, we now have a triangle which starts off at the base of the cube and goes towards one angle over there. Okay, now what measurements do we know? Do we know the line AS?
Yeah.
Did we work that out?
Yeah, we did.
Which is 6 root 2, that's lovely.
Yeah.
Do we know AS is 6 root 2? We know the bottom one is?
6
6
centimeters.
Do we know what SB is?
Yeah.
Yeah.
We just worked out SB as well, that's
Yeah.
lovely.
BS.
So we know this AS, which we worked out over here. We know the SB, which we just worked out over here, and that's the bottom one. So now we're going to recycle two answers from our previous answers. We're going to reuse this and this to label this side, and the box file already given. So let's move over to another sheet.
So, if you copy that sheet, copy up the notes.
Okay. Alright. At the moment in the diagram, you got the triangles leaning. I'm just going to draw the triangle in a two-dimensional format, but we already know what all the lengths are now. So okay, now AS, we label that. We have SB. Now, from our original diagram, AB is 6 centimeters. We know AS from our original diagram is 6 root 2. We know SB, which we just worked out. SB and BS is the same thing.
Yeah,
which is, what was it?
72?
6 root 3.
Oh, yeah, 6 root 3.
There.
Okay, done. Thank you. So from this diagram here, what looks like a triangle that's leaning into, from here, is leaning across the cube towards the back side of the back corner of the shape, A, B and S, it actually transforms into a two-dimensional shape. If you look at that. That's all the correct labeling, which we've taken all the measurements from the previous answers. So now we need to work out, and as the question says, we are interested in an angle ASB, which here,
So, what is the actual angle though?
I'll show you what it looks like on the diagram. Is this one here. ASB is this one,
Oh.
that angle in the triangle. So we are going to work out,
Oh, because S is in the middle, isn't it?
okay, ASB, so it's that angle between A, S and B's angle. So if we look back now, A, S and B, the angle that we're interested in is
It's the S angle.
the S angle there. Okay, now, I'm going to put the three-dimensional drawings to one side, and we're going to look at this two-dimensional triangle. This is a non-right angle triangle, as we can see from the diagram.
Equilateral.
These two look the same, but they're not. That's 6 root 2, that's 6 root 3. Now, if we know three sides of a triangle, a non-right angle triangle, and we want to work out the angle, do we use sine rule or cosine rule?
Cosine rule.
Yeah, cosine rule. Now, cosine rule, let's write it down.
Is A squared plus B squared
A squared equals B squared.
plus C
Squared.
squared minus 2BC cos A.
Okay, that is your cosine rule. Now, what I always like to do is when you look at this diagram, we need to put it into context of the formula. So I'm going to now redraw the diagram, label my own A, B and C's. Okay, then in this original question we have A, B and S. That will still stay as it is. So I'm just going to quickly redraw the diagram over here, or even to one side, and then redo it. Well, let's change it different colour.
So you don't have to say it, just do it.
Okay, so I'm going to call this side I'm looking at as A, leave B where it is, and call this side C. Okay, now, so all I've done here, I've gone from our original labeling to my own labeling. My own labeling now gives me letters that correspond to the correct position in the cosine formula. Don't change camera anymore.
Oh no, what's that?
Okay, otherwise we'll have people get seasick. Come over back and forth. Okay, now the angle that I want to work out, we call it A, so I've relabeled as A. I left the B labeling as it is, and the C labeling. Now, opposite the big C is called the
Little C.
little c. Opposite the big B is the
Small B.
little b. Opposite the big A is the
Little A.
and these little a, b and c refer to the corresponding length of the angles, they are opposite. So now let's start putting these values into our formula and see where we get to. So a squared is going to be 6. And they have b squared, which is going to be 6 root 2 squared. And then c squared is going to be 6 root 3. Minus 2 times by b times by c. Okay, and then time that by cos of a. And the cos okay, I'm just going to double check. Okay, that looks beautiful on camera. Yeah, lovely.
Now you got me all them numbers up.
Okay, what we need to do now, we need to, as Ramiez is saying, we need to rearrange everything to make A the subject. So we have got, you know, every single item here apart from
Big A.
big A. So we need to have something, we need the equation to say something equals big A. At the moment, it doesn't say that at all. So we need to do some major rearranging. So the opposite of adding this is minusing. Opposite of adding this is
Minusing.
and opposite of multiplying cos A by all of this is
Dividing.
divided. So let's do a bit of tidying up and rearranging. So let's change it to blue. So we have 6 squared minus 6 root 2 squared minus 6 root 3 squared divided by, remember, one place where students normally make a mistake, opposite of multiplying by cos A, all of this will be multiplied by cos A, is divide by cos A. That part they understand, but there's also a minus there. You can't do opposite of times is divide and opposite of minus is plus. The minus is not the operation here, operation is the multiplying action here. So cos of A, we multiply by all of this negative number. Opposite of multiplying by a negative number is to divide by a negative number. So you don't reverse both, you reverse just the action itself. So make sure you keep that in consideration. So we have over here minus 2 times by 6 root 2 times by 6 root 3.
So do you have to have the brackets for the 6 root 2? Do you have to have the brackets?
Yes, you have to have the bracket because all that's being squared, otherwise you might square the root 2 by mistake. Okay, now, one final step before we can start putting all of this, you can actually put this all in one go into your calculator, especially if you've got one of these calculators. Okay, if you've got one of these calculators, which is like a Casio FX85 GT Plus with an actual display, then you can use this calculator by putting everything in one go. Okay, here we go, thank you very much. Right, okay, so we're coming to the climax of this question now. Hopefully when we finish this question, then we're going to stop this video and give you a chance to try some questions yourself. And give me a chance to have a little break. Okay, now you need to move so Ifra, what else is here that shouldn't be here on the right hand side? We want to work at A, but we've got cos A.
Yeah.
So let's get rid of this.
So it's cos minus 1.
So we can have here now cos minus 1. And I'm going to cheat a bit and I'm just going to put an arrow down here. Okay, so all of this blue part goes into here. So the cos minus 1 of all of this. Okay, I'll just write it in just for completeness.
Be lazy.
So Mr. Ramiez, have you got an answer for us from the calculator?
35.
Can we double check that as well, please?
Here you go.
Okay, cos minus 1 6 squared minus 6 root 2 squared on top minus 6 root 3 all squared, come down the bottom, and we have here minus 2 times by 6 root 2 times by 6 root 3. Then you close the bracket there, that's good, that's lovely, and that's all cos minus 1, yeah? And then you press equal for that one, and that gives us an answer of 35.321 dp. So, at the moment,
That's what we got in the last answer, do we? 31.3.
35.264
Or, yeah.
is equal to A. So I'm right down here. 35.3 degrees to 1 decimal place. That's the end of this video. Hopefully, I'm sorry about all the moving around the camera. We're just actually making this video in the student's home as I'm teaching the students. So there was quite a bit of there's quite a bit of moving around and cameras just moving forward and backwards and up and down. So sorry for all that. And hopefully you can benefit from the actual video itself. And we'll see you in the next video. Thank you very much for joining us. And until next lesson, inshallah. Assalamu alaikum.